Hello everyone. We're going to learn today network protocols. I want you to recall the concepts of networks that discussed last week. Today we'll do a little bit of the hands-on so that you can get a clear idea and understanding about network protocols. Let's start with 7 layers of OSI models. As you can see here, from physical layer to the application layer. At the top of the application layer, the protocols available at this level, this layer, usually the application-related protocols, HTTP, FTP, SSH, DNS. And in the presentation layer, some of the data types like JPEG, and also SSL, SSH, MPEG. In the session layer, which means from on your platform, there's some of the network connections, particularly to you, each individual user. There's a session. So there's APIs, sockets, and WinSock. Those are the protocols. In the transport layer, then we have TCP, UDP, two of the typical and also very, very important network protocols. And also we're going to, the hands-on exercises, some of the network connections through TCP and UDP protocols. That's what we are going to do. Below this transport layer, then there's IP and Ethernet, and then physical connections. To TCP and UDP, IP network connection must be ready, must be available on top of these IP connections, and then we could share the data, either TCP or UDP. In addition to these IP internet protocols, there may be some other the connection checking protocols, for example, ICMP and IPsec, IGMP. Those are the protocols that may be very, very critical for cybersecurity defense and attack. In the data link, there's Ethernet connections or PPP, switch, bridges. At the bottom layer, this physical connections. So network connections can be established over coaxial cables or fiber optical cables or wireless communications, and so on and so forth. So, and also we learned how to download and install Wireshark. Wireshark is very, very useful the tool to analyze network packets. This is ready for us to use as an operator. But if you want to develop even further and more intelligently, or if you want to add machine learning concept into the network packet investigation, then you need to do the real codings. That is a development side of the approach. This is operational approach. So we'll go back to this Wireshark level of the analysis. So if you look at these two things, I believe this is, if you see here, currently it is marked ARP. If it is ARP, then 0806. I want you to look at only these last 2 bytes of the first line here, 0806. This is an indicator that says the protocol is ARP. Other than that, if it is a TCP, then there is a 0800. Remember that here IP, ARP is somewhere, ARP is available on this Ethernet frames. If you're working on Windows operating systems can make the network packets available above network layers. So on your Windows platform, you cannot read anything about this Ethernet level, the packets data. But if you're working on the Mac platforms or Linux and Unix platforms, then you can see this from the bottom of this 7 layers, so that you can see Ethernet related protocol, which is ARP, address resolution protocols. If you have a resolution, the ARP protocols available, which is like this is available only on your Mac or Linux, then you can see 0806. Therefore, this is a packet for ARP, address resolution protocols. From this, TCP and all others may be available for anything for Windows. So they can see here 0800, 0800. That's what I said here. If you can see 0806, then that is ARP protocols. So even low level of packets can be analyzed. If you can see 0800, then this is the TCP layer, either transport layer or network layer. This is data link layers. Looking at this last 2 bytes, if it is a 0800, then that is IP type, 0806 ARP, 0838, 35, 90, 9B, FC, 0137, that is all others. Okay, if it is ARP, then in other words, once you have Ethernet levels, the packets code 0806, then ARP exchanges messages between a source and destination device. The source device seeks to perform the resolution, and the destination device responds to it. So here, basically, if it is ARP, let's say this is a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 13th and 14th bytes. This is 4, 8, 12, 4, 12, and 13, 14 somewhere here. This is sender hardware address. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. Yeah. And IP protocols at the Ethernet type, then the indicator shows 0800. In this case, that is IP. Therefore, TCP and UDP is available. This is IP forms. IP characters. See here, datagram based 8 IP characteristics. That's datagram, and then unreliable, best effort to delivery, no delivery guarantees at this level, and 32 bits address. So via data packets, network layers. Datagram based IP packets, then that is header and payload available. What that means is that if it is IP packets, then all above this is a header. Header plus this is a payload. Some additional options if it is needed, then this space may be filled with that. Other than that, payload. Right after this source IP address and destination IP address. And UDP, this is still datagram based, but this is a connectionless. UDP. And TCP, then that is connection oriented. That is the difference between TCP and UDP. UDP is connectionless. If it is connectionless, then application handles errors, which means if you are sharing data over UDP, then if there is any error takes place, then your application needs to handle it. The network protocol does not do by itself if it is UDP. But on the other hand, if it's TCP, then applications does not need to error checking because protocol itself is a connection oriented. So it knows it checks if there is an error, then error may be checked, and some of the policies may be applied. Either ask the sender to resend the packets, something like that. There's UDP and TCP. UDP is a short architecture. On the other hand, TCP longer, right? ICMP, there's an Internet Control Message Protocol. This is also the level of the network layer. Then you can see, usually sends error messages and some of the communications checkings, ICMP. For example, if you want to send a ping command to see if destination server is alive, then you can send the ping, and then the destination server may pong back to you. So there's a ping pong protocols. That is running on this ICMP. Hands-on practice, we'll do, knowing these protocols, we're going to build client and server programs. So depending upon the protocols. Therefore, we have, for example, if we want to connect over TCP, then we need to set up a TCP server and TCP client. So TCP client can talk to a TCP server. Similarly, if you are going to use UDP, then we need to set up UDP server and UDP client. And UDP client can talk to UDP server. Okay? To communicate between client and server, then because this is IP based, remember TCP and UDP, that is running over IP. IP is in the network layer, and UDP or TCP in the presentation, transport layer. So IP address it needs to be given. And for the same IP address, depending upon the port number, therefore, we will have different port transport layer communications. So using the port like this, then we can see which port that I want to get in. Okay. So, and the point of connection can be identified by IP address and port number together. So sockets, you need to define at the user application layer. That's what we're going to do. The implementation of TCP client and server or UDP client and server will be practiced next week, not this week. This week we will look at the concepts only. So you can understand at the application layer, you need to create a socket objects. Okay, then socket object may bind to a port, specific IP address and specific port. Then you can send the data, and then you can transfer it to the destination through transport layer. From the destination, if data needs to be returned back to you, then through this transport layer, and then there is a receive from the statements, therefore you can receive it. Okay, so basically this is an application layer, which is a user space. You need to use this kind of statements to communicate with the destination, either TCP or UDP protocols. So once you have this, then all other details can be handled by at the level of operating systems and also over the networks. Okay. So what is a socket? Socket is an interface. So if you are running on UDP, then socket object can be created by socket object constructor. Okay. If you are going to run over UDP protocols, then you need to use a sock dgram. If it is a TCP, then sock stream. So once you have socket objects, then you need to bind. This socket object has a method bind. That bind takes parameter in a tuple format. This is tuple, right? Outside the parenthesis is nothing but a function, right? Methods. So inside the parenthesis, this itself is a one parameter. That one parameter is in the form of tuple. So first element in that tuple is the IP address, and second element is the port number. This is my port number. This is the IP address of the opponents. So if I want to receive only the data from 192.168.4.67, then this is fixed. I do not want to hear any other than this. If we open this, then I want to hear anything incoming, as far as packets coming through these port numbers. That's what it is. UDP is connectionless. There's no connection. On the other hand, TCP, connection is needed. To establish a connection over TCP, then you have to listen. By listen with 5 means I want to open the connections 5 different connections. Simultaneously, that is also possible, but our current coding skills, we do not actually set up 5 connections that can run simultaneously. In order to do that, then we need to learn multi-threading coding skills, which is not, that needs more understanding. So we don't do that. So anyway, only one connection, one connections. And if there is a request from client, then your socket object can accept it. By accepting that socket, then connection is by default established, and therefore we have a connection object and also remote IP and remote port. By these points, either TCP and UDP, then we are ready to receive data from a client or server. Therefore, here still use that socket objects all the way. Socket object receives, socket object send. But on this TCP, socket established the connection, and after that, connection receives a connection send. How many connections that we can make this? 5 connections, right? So simultaneously, 5 different connections can be served if we do this TCP communications. That's what we will do here. Socket stream, that's a packet type of TCP, socket DRAM, that UDP socket types. This is a reliable delivery. UDP, unreliable. This is auto guaranteed, no auto guaranteed. Connection oriented, this is no connections. So pictorially, you have destination. This is your application, your local. You set up the socket objects, then order guaranteed. So depending upon in certain order, this socket send out data to destination and receives order based. Right? This is a TCP. But if it's a UDP, the socket object has 3 different the data to send out. Then you can send out to destination 1, destination 2, destination 3. So it didn't care about the order, didn't care about the success of the deliverers. Only UDP send out. Like if you are listening to MP4 music, then and sender simply keep sending out the MP4 musics. It doesn't care whether your headset receives every single MP4 data packets. Keep sending to you. Therefore, when you listen to that MP4 music, sometimes there's some packets dropped, right? Still okay for you to muse the music. In the case UDP protocol is used. On the other hand, if you are sharing emails, when you receive emails, you don't really see the emails not complete, part of your email dropped, and yeah, because of some reasons over the network, you don't see such the data sharing these days. But decades ago, with some issues, right? Some even that is a TCP communication based emails. Some part of email may be lost, but not anymore. Now it's completely all the time. It works fine. Connectionless services. If it is a server, then your socket created and bind to the ports, and immediately you can receive. This socket can receive. Client, same thing. Socket object is created and bind to the IP and port number, and then immediately send out or receive from. That is a connectionless service. So it is like this. If it is a server, then socket object is created. So S is a socket object and bind. This means I want to receive. I don't really care which IP address sending to me. As far as it comes through this port number, I'll be okay, and then I can receive the data. Okay, client, same thing. We create an objects, and then simply send out. We set up the address and send it to that address. Okay, it's kind of a binding, but so one time connection, and then if connection complete, then connection is lost, right? That is UDP. There's a connectionless. On the other hand, if it is connection oriented, like TCP, then socket is created and bind and listen and accept. At this point, connection is formally established, and therefore that specific connection can send and receive data. That is in these red lines. Client, socket is created, and the connection is receive the connections, and from there read and write. So if you see the code, then socket object is created and bind and listen, and when there is a connection request from a client, then accept it immediately. Connection is established. Therefore, you have remote IP and remote port numbers. Reason that we needed a remote IP and remote port number is because we want to communicate with that remote client, right? So using this RMIP and RMPT, we can send it back to the user. I mean the client. So connection from this point, the connection is handling that. And then client, simply by connecting this particular, the server IP address, and with a specific port number, then connection is established because server is ready to establish connections. So once you send this connect method, then the server keep listening to any packets from client. Therefore, this packets coming into the server, then server accept it, and then connection is established. From that point, then we can send out and receives. Okay, this is basically what we had, and I want to point out some of the IP, some of the Wireshark. Here, application and Wireshark. And then right now I have this interface, Wi-Fi EN0. This is okay with me. And then I want to start the capturing. Then packets are established. Here in this filter, we can, for example, set up ARP, and all ARP packets can be coming through. So if I click one of this, then you can see here 0806. This means this is ARP. Okay. On the other hand, TCP, then that is, for example, this, then yeah, TCP frame trying to see 80. Let's see. 0800 TCP 0800. This is something further. TCP 06DD 06DD, all 06DD. I believe that is this. If it is TCP 0800 or 0806, TCP 0806, 0806. Let's see. TCP 06DD. I think this is something that we can see. Let me find out some here. So TCP 86 DD 0800 or 86 DD. Strange. Let me see. Anything that I want to. (86DD) ARP 0806. But anyway, this is the way that you can. I'm not sure why this is. 0806 is okay, but TCP, let's say UDP. Oh, we need to say IP. Yeah, I'm sorry. IP. Yeah, 080, 0800. I'm sorry. 0800, that is IP. Yeah, TCP is different. This is IP. Remember here, 0800, that is IP, and 0806, that is ARP. Perfectly, that's, if any IP here, then that is 0800, 0800. If that is ARP, then we will have 0806. This is 0806. Okay. If we were looking at TCP even further, TCP is over IP address, then and then here we do destination what you can read this. For example, we have here TCP. So TCP has first 8 bits is for source port, and the next 8 bits, no, 16 bits source port, 16 bits destination port. So if you see here, 16 bits means here 16 bits, 2 bytes long, right? So that is destination. This is a 1, 2, 3 destination. 1, 2, 3, 4, 5, 6. Source. and type. Oh, sorry, this is Ethernet, right? This is IP, and this is a transmission control, TCP, and this source port, so 2 bytes long, that's 2 bytes, source port 2 bytes, destination 2 bytes again. This is the destination, that is for 2 bytes. Source port and destination port, and then following stream index, what it does is that after this sequence number, that is 1, 2, 3, 4 byte long sequence number and 4 byte long acknowledgement number. So 4 byte long from, this is 2 byte long for source port, 2 byte long for destination port, and after that 4 bytes. So from here, that is 4 bytes, A4, F4, 31, FF, those 4 bytes for, this 4 bytes for the packet sequence, the sequence number and acknowledgement number, and after that data offset and reserved. So this is 4 bytes and another 4 bytes. After that 80, this is 1 byte. This 1 byte can be divided into 2. First 4 bits, 80 means, I believe that is a 0, 1, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, that is a 0, 8 in hex. So 0, 1, 0, 0 in data offset, 0, 1, 0, 0, then depending upon this description. So if I bring this data description here, 0, 1, 0, 0, this is data sets, data offset 0, 1, 0, 0, TCP header, 32-bit word. It's not much that we can say, but here, after that, we have 0, 0, 0, 0 reserved, right? So reserved 0, 0 means for future use. This is for future use. And after that, this 8 bits is for the flags. So next 8 bits in our real ones, next 8 bits, this is 8 bits. 1, 0, which means 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0. Okay, 0, 0, 0, 0, 1, 0, 0, 0. Actually, it is a 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0. So 0, 0, 0, 1, 0, 0, 0, 0 means flags 0, 0, this is 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4. This acknowledgement is only 1, all others is 0. That's what it is here, this packets. This acknowledgement is this flags. Yeah, this 1, 0, that is the flags. That means acknowledgement is only set, see here, and all others is 0, which means accurate not set, congestion window reduced not set, echo not set, urgent not set, push reset, synchronize, final bits, all are unset. Only acknowledgement is set. What that means is that this package is for the acknowledgement packets. I'm not sure which one is it. Yeah. So this way, this network packets can be analyzed manually. This manual, this is real handy because it automatically, this guy says, hey, this acknowledgement is only set, right? But you can make this in codings. So automatically you can do every packets continually, and then you can scan the packets that you want to. For example, hey, I want to see if there is any reset bits is set, then we can get it, right? So that is handy, and that's more like network packet inspections in developers' perspective, not operators' perspective. Operators can do only like this. Okay. All right. Hope that you can get a little bit more understanding. So next week there will be recordings posted so that you can build exactly the way that you can see on your applications. Actually, what you need to do is that you need to, because you have, if you are going to build a TCP communication, then you need to open two programs at least, TCP server and TCP client. You have to first run TCP server. Then you can run TCP client. From there, TCP client talk to TCP server. TCP server may reply back to TCP client, back and forth, until you close the connections. So that's kind of the practice will be posted the next week. And accordingly, I want you to do the last homework assignments. Today, you do not have homework assignments. But next week, you will have the final homework assignments, which is for building TCP client and TCP server, UDP client and UDP server. All right? Thank you.